Like a lot of places this summer, it's been really dry here, and my lawn's been drying out pretty badly. So it's time to fix the watering system. Ever since we've lived in this place, it's had an automatic watering system. It's this Nelson Easy Pro. So this is what the watering system looks like outside. Pretty mongrel. All the wiring's just done with screw connectors. No protection against corrosion or anything else out here. The manifold's just hanging on the tubes, which I don't really understand because they did go to at least the minimum of effort to put up some brackets. Well, they're pretty wobbly. So this manifold, I guess, was supposed to be back somehow mounted against those brackets. This here's the rain sensor. Yeah, it doesn't work. On the manifold they put a shut-off valve on each of the valves, but unfortunately this one has developed a split in the actual valve body, so that definitely needs replacing. I don't know who installed it, some previous owner. When we first moved in, I put a bit of effort into setting up the 5 watering zones. I added a relay. But now, of the 5 watering zones, only 2 are still working. So let's do some troubleshooting. First thing I see right off the bat. Oh yeah, they're nasty. Should have replaced them more often. Now, while different models of watering computers probably have different features and a different number of zones, from what I can tell, they all have pretty much the same basic setup. Like in this case, this is, I think, the rain sensor, which is just a switch. All of these machines work on 24-volt AC outputs. This one gives you 2 different common terminals. The first common goes out to all of the solenoid valves outside. The second common and the pump terminal are turning on the 24-volt AC relay, which turns on my main pump. Because the contacts in my main pump switch need a different voltage. And then I've got 6 zones, of which only 5 are connected. I need to note the color of these wires, because when I'm troubleshooting outside, I need to know which zone is which. So which valve 1, 2, 3, 4, and 5. In my case, currently zones 1 and zones 4 are actually working. I downloaded the user guide from the internet. It had no real useful troubleshooting information. So we're going to start looking at the continuity of each of the circuits. Any voltmeter will do. Put it on the ohm setting. Put one of our leads on common. Doesn't matter which common. And now we can start measuring. So the first pin here, nearly 320 ohms. Now working through the various zone valves. So zone 1. 40, you expect a bit of resistance, that's normal, you'll be going through the coil of the solenoid outside, so yeah, 41 ohms on 2. Zone 3, zone 4, and the same on zone 5, so that would indicate that all the wiring's actually hooked up normally. What would it mean if you had 0 ohms across one of the coils? Well, it probably just means the wires become disconnected. Maybe you've hit it with your lawnmower, maybe it become corroded and disconnected, so you'll be looking for a broken wire. On the other hand, because you're measuring through a coil, you should have like 30 to 40 amps. So what would it mean if you had like a short circuit of only 2 amps? Well, it probably means you've burnt out one of the coils, and you'll need to replace the solenoid. For the next check, we'll set our voltmeter to measure AC voltage. Let's see if this unit can actually power each of those circuits. So we go around to the manual on my one. It'll wait 5 seconds, and let's just measure the AC voltage across that pin. Looking first at the pump relay, which we know is working, and there's our 24-volt AC roughly. Now looking at zone 1, and there's also a signal. Good. Let's move on to zone 2. Okay, I've got no output here on zone 2. So it looks like the watering computers may have lost one of its zones. That's not good. Now let's measure zone 3. Okay, I've got my 24-volt AC, that's fine. Okay, so that troubleshooting bothers me. I assumed it would be some problem with the horrible setup outside, but let's have a look at the actual machine. So it doesn't come out yet. Looking up under here, it looks like there's another support. So I'm guessing that that's under the battery compartment. So why does this not want to come out? I think there's another screw. Sure enough. This backup battery is obviously dead. Died of lack of maintenance. I gave it a sniff test. I didn't smell anything like popped or burnt. I don't really know much about electronics. So yesterday I did a tech call with my mate Hamish, because he was Air Force trained avionics before he went flying. And the first thing he did while setting up the call was notice electronic gunge all over the place, and I had to clean the board. So then on the call, he patiently listened to me expound on my unfounded theories of what I should do to troubleshoot this thing, until I got to the point where I mentioned, oh yeah, one of the batteries leaked. At which point, I think his exact words were,
now the truth comes out.
I've now been tasked with cleaning this board properly. If I'm lucky, it'll be recoverable. He thinks that the electrolyte run out from that battery is probably causing some shorts somewhere. While I'm at it, I'll also clean up this one. Right, so I'm going to put it back together and see if that miraculously solved the problem. Kind of doubt it, but hey, sometimes you get lucky. Throw in a new battery. That's good. Brain's back alive. Let's see what happens when we plug it back in. That wasn't good. Okay, the 24 volt AC is slightly too high, but it's being resupplied. Wait, but now it's come back and it's giving a no AC power warning. I did another tech call with Hamish, but we really couldn't get to the bottom of why some of the channels weren't working. But then it started raining like crazy on the way to the Depeche Mode concert, so who needs a watering system anyway? Yeah, it's only end of July. It's going to be more hot weather to come yet, so let's get cracking. Let's get this fixed. Need a second spanner. So there's the split in it right there. To make the hemp grip on the threads better, a plumber who once did a bit of work for me recommended just score these threads a bit before you start. Now that sounds pretty brutal, but if you have a look at it, that's what they're now doing in the factory. Hey, check this out. Went back to work on my watering system, and look at this. Don't often see snakes around here, but that's quite a decent sized one. Well, for here. No idea what flavour it is, but I'm kind of going to need to get rid of it because I need to get in there. Right, Mr. Snake, here's Mr. Stick. I need you to go because I need this spot. Come on, get out of here. It's making hissing noises, but it's not moving. Come on, get out of there, you bugger. There you go. Come on, keep going. Get away. See, it doesn't want to go out into the open, but you're going to have to. Up. There we go. And you're away. Right, to start with, I've just got a bit of wire holding it roughly in position. Now I'm going to make up just a strap clamp to support it.
After procrastinating a little, wondering what I would do about the controller, I finally decided it's time to start learning Arduino. Let's make a new watering controller. A simpler solution would have been two 4-channel Sonoff units, but we're not looking for simple solutions here, are we?
It's not great, but it's better supported than before. Mail time. It's just my USB hub. But wait, there's more. Oh, you're kidding me. That's the size of an Aduino Nano? That's tiny.
Now, I've never done anything with microcontrollers before, and I've never ever programmed anything in C. In fact, I've only ever done a course in Python about 5 years ago, which I never really used.
24 volt AC to 5 volt DC. Perfect.
Oh, and I did do a year in computer studies back in 1985.
First thing to do, of course, is a blink code. Let's change the number of flashes. It took me a bit of faffing around to get this working because it's the cheapest and nastiest clone of an Aduino Nano. Turns out it's got a different serial port chip. You have to download a driver called CH340. Plus, you have to turn the processor to the old bootloader. But once you've done that, it works fine. It's super useful to use the serial monitor to be able to see what the program's doing. Just did a quick check there. So initiated a serial whatever and printed just that running variable. So with the whole blink code thing up and running, it was time to move over and try out the relay board. Let's see if I can get that working. I've only got the middle 6 relays connected, but cool. This is a little amplifier board for K-type thermocouple control. It's another project. This is the real-time clock module I need for my watering time at work. So I've now wired in this little real-time clock module. So one of the cool things in this Arduino interface is that there's a whole bunch of examples. So I just used the example to set the time of that clock. That's already been done. If we look in the tools, look at the serial monitor, it's set the time already. Now I've added a switch. This simulates my rain sensor. Alright, so now while it's raining, the system's suppressed. Stepping through here. As soon as we turn the rain off, turns on the main pump and goes stepping through the zones. So I started off writing an entire program before I got the boards or anything, and well, that doesn't really work. When you program as crap as me, writing a program like that is so full of bugs and errors it just wouldn't compile. I restarted from scratch and just started with the most simple things. First, get the board working. And now, as I'm starting to go through and add the functionality, I still have big issues like it took me probably 20 minutes to remember that if you want to compare two things in C++, you need double equal signs. Those sort of things drive me crazy. It takes me ages to find them. Right, the next bit, I've used the second half of the switch as my heatwave switch. I'll have to do that with 2 physical switches, but for start off. So it's not raining, it's not a heatwave. Okay, we cycle through at normal speed. Now the heat wave comes, and now we get 50% more time for each watering. I started off using the alarms library to trigger my watering,
But the issue I was having was it would trigger fine, but then the trigger was sticky and it just kept watering and watering. So I was talking to one of my friends and he suggested using ChatGPT to try troubleshooting. It's pretty fascinating the way this AI stuff works. I even gave it a shot at writing the whole program. What I found was there were inconsistencies, like the start time system and the zone time system were completely separate from each other in the program that it wrote. But I did pick up a couple of lines of code and some ideas of how to trigger the system that did end up fixing my code. Once I got my code running, it was time to make up an adapter plate to mount everything into that existing housing. And there it is, ready to go to the printer. Right, let's see how that works out. There's a rib here I need to put a notch out for. Rib there, rib there. Looks like that'll work nicely. The real-time clock can go on here. But my Aduino board, I got the height of that completely wrong. Need to adjust those two. My 24 volt AC, and then I got a little 24 volt AC to 5 volt to run the Aduino. So I'm going to need some sort of a plate for them to mount on. Right, that blade's too coarse for thin sheet metal. Well, it didn't come out as pretty as I would have hoped. It's now all wired up. Didn't bother showing the wiring because that's kind of boring. Right, time for test. Just given it a fake time on the Aduino. Well, after a couple of minutes of troubleshooting and wondering why the real-time clock is not initializing. Ta-da! Go! Okay, so I've got my zones connected wrong. I've connected my pins to output 1, 2, 3, 4, 5, and 6, but it's now 8, 7, 6, 5, 4, 3. So I probably need to take that off, rotate it, and put it back on the other way. Done. Well, maybe not quite done. Why is it when I finish a job, my bench always looks like this?
And this. This week I'm doing a Patreon and members live stream. I got some thoughts on programming I'd like to share with you. I'd like to see you there. Thanks for watching.